All right, hello everyone. Welcome to Office Hours, where we answer questions, give philosophical perspectives, formulate and explore arguments, and deep dive into particular topics of your choice. Ian asks me to review the mathematical challenges to Darwinism. This is one of the most pleasant sit-down philosophical discussions I've heard in a while, and I've heard a lot of them. Top 5, top 10. It's very, very good. Just casual reading. It's just pleasant to listen to them talk. This is also a subject I have looked forward to diving into ever since I first saw Vox Day weigh in on this question with his mathematical challenge to Darwinism, which I'm not sold on, but fascinated by. And I want to see it explored further. I want to see it challenged more. And entertained more. We'll get into why it's not being entertained so much and my opinions on a second. First, let's clarify a few terms, because this is one of those things that's like very commonly misunderstood. Darwinian evolution is not just change over time. Okay. We have known about selective breeding and inheritance for thousands of years. This is not new information. We had, is it Mendel or Punnett squares? One of these monks in the Middle Ages, looking at peas and different genetics there in like the 1600s. We've known about, breeding livestock and all that for, again, as long as we've been pastoralists, which is a really long time and probably further than that. We domesticated wolves, for God's sake, So Darwinian evolution is not the claim that genetics is real or that species can change over time. Darwinian evolution is claiming that this process of selective breeding not selective breeding, mixing my authors a little bit here, this process of natural selection, the opposite of selective breeding, natural selection, from pressure, and Kostin Alamariu has his own opinions about Darwinism, which are worth reading in Bronze Age Mindset, that this can explain the origins of new species, not just changes within a species, but the creation of new species from separate species which cannot interbreed with each other, right? Because that's one of our core biological definitions of what a species is. And there's all kinds of biological reasons why different species can't breed with each other. This is a much more profound theory than it sounds, because many people, when they first heard this in Daniel Dennett's book, which I haven't read, but I kind of can glean the thesis from based on the title, Darwin's Dangerous Idea, is that this idea is so much more than just the origins of species. It might have something to tell us about the origins of complexity itself from simplicity, which is a very, very deep idea. So big claims require big evidence, right? And in the world of biology, Darwinian natural selection is one of the theories that has the most evidence of like all theories out there. There's so much evidence. There's mountains and mountains of evidence. But there are also holes. And some of these holes are not just like gaps. We'll get into gaps a little bit later. But they seem to be theoretically unfillable holes that break the chain that is required for us to believe in this thing. So before we get into the details of that, I want to frame this discussion, because we're about to get into some really unfalsifiable territory. We're not just talking about, and I think this plays out in some of the characters in this discussion too, because we've got mathematicians and philosophers, not just biologists. there was a very famous book that came out in, gosh, what was it, like the 80s or so, called The Structure of Scientific Revolutions by Thomas Kuhn. And this is kind of a postmodern sociological approach to science, but I think it happens to be correct, which is that science as a social consensus, not this naive pauper like falsification theory, does not advance by falsification. That's theoretically how it's supposed to work, but that's not actually how it works descriptively in practice. What Kuhn says is that there's a kind of process, and it's not just like, oh, this gets falsified, so then we go to the next thing, and then that gets tested and it survives, and then we do other things. It's more like there are these waves, and things will be tested to the point, and only after it's been tested to, well, let me describe the sequence. A thesis gets advanced. It is simple. It is clear. In its simplicity, it is beautiful and attractive. Lots of people are drawn to it. They take it on. But then people start to create challenges to this theory. The theory, if it is to survive, must offer answers to these challenges. Sometimes these answers require tweaking the theory a little bit. Oh, it's not Darwinian evolution by natural selection. Now it's Darwinian evolution by natural selection plus punctuated equilibrium, or whatever the case may be. Maybe more problems emerge. Maybe the theory has to get tweaked again. Oh, that 37th model of global warming didn't work, but this 38th one fixed those things. We really got it figured out this time. But as the theory acquires more sort of ad hoc Frankenstein modifications, it becomes this cumbersome, complicated, and importantly, and this is not Kuhn's language, this is my language, it becomes ugly. And eventually, the weight of all of these gross additions becomes too much for the scientists, and suddenly, like a freaking like a real estate in 2008, everyone just drops it, right? Everyone's just like suddenly decides, nope, we're not doing that anymore. And then you go to the next thing. That's when the scientific revolution happens, and we have a paradigm shift. We move from one belief. We all believed in Darwinian evolution this year. Tomorrow we all believe in intelligent design, or whatever the case may be. And there's an aesthetic component to it. There's a social component to it that Kuhn focuses more on. And it's a cumulative social process, not a logical one. So, what we might be looking at here, even if, and I'm going to offer some counters to what David Berlinski and Stephen Meyer and David Galerner are saying. But regardless of my counters, maybe I'm right, maybe I'm wrong. I'm probably not more right than these three guys who have dedicated a fair amount of time and effort and who are very smart to studying this. But even if I was right, there still might be a scientific revolution underway, because Darwinism might simply become too ugly to survive. Food for thought as we continue. So let's get into the details here. Is Darwinian evolution wrong? The challenges being invoked here are essentially gaps in our understanding of the process. How it's not just did this thing happen, but explained to be the mechanism in infinitesimal detail of how we got from this species to that species. It's a lot of how about this, how about that, and there's I wrote down 3 challenges. There's probably more. I watched the video 1.5 times. I probably should have gone back and watched it again. But the big one and the really interesting one is a problem of precision. That is to say, new mutations for an organism to begin to change must exist early on in the organism's development in order for them to be able to be built upon. But the problem is that, according to these guys in the literature, it looks like every large mutation like that happens early on that we know of, that we've ever seen, is fatal. So how did we get mutations that are big enough in order to speciate? And the way Berlinski puts it is like, if you get these mutations too late in the process, then it doesn't matter, obviously. And if you get them too early, it doesn't work and they're fatal. So there's a timing problem, and there's a precision problem in the matching of new mutations to selective events, basically. Because you might have a case where, suddenly, this is a good example. It'll segue into an answer. Suppose you're a barn swallow, right? And suddenly you've been existing on one continent for 1,500 years. And then suddenly, in a period of only 40 years, a bunch of roads come in, or a bunch of cars driving really fast, and they start killing off like half your population. Not only are they killing off half your population, but big trucks come through underneath overpasses that you like to nest in, right? And those big trucks create such a huge wind vacuum that they actually suck your fellow birds down into the roadway and kill you more efficiently that way. If you don't already have some mutations on the field in your population that can be selected for in the selective process, then you don't get natural selection. You just get annihilated, right? You need to have some mutations that exist there in order to allow for the change. You have to have, what we've seen is some birds with slightly shorter wingspans that are less susceptible to that backdraft, or whatever it's called. I'm sure backdraft is not quite the right word. And indeed, we have seen the population of barn swallows. I think it's barn swallows. Whatever the birds are that nest under the underpasses. Their wings have been getting shorter because those birds are more able to survive. Things like that. But the big mutations that can potentially lead to speciation are, in every case we know of, fatal to the organism, like at a organism level, not even in an environmental level. So that's a problem. We don't have evidence of that. There's also an interesting problem of chemistry that they bring up, and it turns out Darwin didn't know we were looking at organisms back in the 18 and 1900s at a very broad kind of structural level. A gorilla is very similar to a human, but we have a kind of different shape to it. Like they have thicker arms and thicker bones, and their backs are a little shaped, and their legs are kind of smaller, and their shoulders are a little bigger, and they're hairier. And that's the difference. That's the big difference. Well, it turns out cells are a lot more complicated than Darwin could have possibly understood. So gorillas and humans are not just different at a macro structural level. We're different at the cellular level, like very different. And new organisms require new proteins, and basically what they're saying is there does not appear to have been enough time for these things to have come into being. And this is this conversation happened before Vox Day was giving his criticism. So I wonder if he was influenced by this. And he said, this is the argument right here. And then Fox Day expanded a little bit with his what is the average mutation rate question, which is a very poisonous question. But there's also a bit of Michael Behe in this question. Way back in the, I want to say early 2000s, a molecular biologist named Michael Behe made some assertions that there are certain things in the body that are, in his words, irreducibly complex. And he gave as some examples of this the human eye. He gave as an example the platelet cascade in the blood, where if you assume a process of sort of gradual building of parts, at every stage of evolution up to completion, you would have a completely non-functioning item. So imagine you're building an arch bridge, right? You need 7 stones that are all stacked in an arch together. You need all 7 of them, right? If you have 6 of the 7, it just collapses in on itself, you know. Now, I chose the arch bridge example because it's one of the examples given by the counters to Michael Behe. They say, well, here's how you actually build an arch bridge. First, you begin with a form, then you lay the bricks on top of the form, and then the form is pulled away. And this can happen in biology too. We have all kinds of parts of our body that are residual components from things we once had, but which we are beginning to lose. And mutations are not just additions, they are also subtractions. So you can end up with things that are functional in one way, and then they add a few things, and then they become functional in a new way. And then the old parts that are of this component, a limb, a function, whatever, the old parts that are no longer necessary get are erased by selective pressures in the same way as anything else for efficiency. And voila, you can end up with something that's irreducibly complex, supposedly, through a natural selective process. This is all speculative theory. I don't know if this has been proven or not. I'm not a biologist. I'm just reciting what I've read over time. So what we have here are essentially arguments from incredulity and gaps. We don't understand how the Cambrian explosion could have happened. We don't understand, maybe there's some other explosion that happened before that we haven't seen yet. We haven't just uncovered. Who knows? But we can't imagine how this would work. And this used to be back in the late 2000s, early 2010s. There's this argument called the God of the Gaps argument. And this was kind of a warning that you say, you don't want to make a God of the Gaps type argument where God lies in the gaps between science, because science is always expanding and the gaps are always receding. So if your God lies in the gaps between science, then your God will be always receding as we learn more. But I think what we're seeing here, and what this has sort of been something you could come up with if you spend any time in philosophy, is that the gaps are only receding if you don't have a cast of professional gap finders that make it so that the gaps are always expanding. And the knowledge is trying to expand, but it's not expanding as fast as the gaps are being expanded by these kinds of questions. And this brings us to a philosophical concept that I've run into and was writing a fair bit about. In fact, I discussed it a little bit with my friend who I will call John in my the latest Caffeine Stream podcast, which I put up a few days ago, or this morning, actually. And I wrote about extensively in Descending Odin's Throne. And that is this Greek word aletheia, which gets translated as truth, but it means a lot more than that. It means much more than that. It goes back to Parmenides, and as well as Socrates and Jesus, of course. But Parmenides is really the one who gave aletheia its connotation that we have today. And I was reading this wonderful book that I love to recommend to everybody called Logos and Mythos. It's edited by William Wiens. Just a fantastic book on the intellectual evolution, we might say, from Homer and poetry into philosophy, right? And what's described in one of the essays there, I forget who the author is, because Wiens is just the editor. Let me look it up real quick. Aletheia from Poetry into Philosophy by Rose Cherubin. Very good essay. Aletheia is not just truth in the English sense. The "a" prefix is like atheist, right? Not with God. A is a negating prefix, so it's not letheia or lethe, which is like oblivion. The river Lethe is the river of forgetfulness, the myth of air and the Republic. It is not covered over. Aletheia is that which is uncovered, but that's a very literal meaning. How it was used is more like not unnoticed. It's like grasped. Think of it. It's like what is that is grokked in the not in the modern like Twitter sense, but in the Heinlein sense from Stranger in a Strange Land, like really understood in totality. But it's not our knowledge. It's what is. It's the truth. Although I suppose it's not separate from our knowledge of it. So, because what is to eon, which is related to aletheia. And according to Parmenides, aletheia is bound by dike, which is like order and regularity. It is bound by ananke, which is like constraints and causality. And it's bound by moira, which is unchangingness and the singularity. I don't mean singularity in the text sense. I mean singularity is like it's unified. So what you end up with is a standard for justification of the truth that requires an understanding of the whole, of the totality in its unchanging, eternal, uncontingent fullness. This is an impossible standard. If you hold any theory to this standard of aletheia, of truth, you will poke holes in it, because no single theory is a theory of everything. By the way, if you've ever wondered why the West is obsessed with finding a theory of everything, you get, whether it's in physics or German idealism in the philosophical world, this is why. This one Greek word motivates this whole thing from Parmenides. And the standard of justification that seems to be being expected of Darwin by these three philosophers here is sort of the standard of aletheia. They're saying, is it true in the aletheia sense? Like, can we explain every individual component of it down to the most minute details of proteins and cells and so forth? Perhaps we've expanded Darwinism a bit too far. Because here's the real question. Did natural selection, the process of natural selection, ever, even once, create a new species from another species? Because if the answer is yes, then Darwinian evolution is true. That's it. Now, there are a bunch of other interesting questions that are separate. Questions like, where did life come from? Was the creation or modification of life guided by some other force? Perhaps an intelligent force. And then there are other questions that they get into towards the end, like what is consciousness? Is consciousness even an interesting question? Is it really as profound as people make it out to be? Is creation good? That's a question that might follow if you assume it was intelligently designed. Just how intelligently designed was it precisely? All sorts of other questions are out there concerning life, its origins, its nature, and so forth. That is not, I don't think, a fair standard to hold Darwinian evolution to. Can it answer all of these questions in totality and in an uncontingent, singular, complete fashion? And by the way, the answer to the question, did natural selection ever once create a new species from another species? I don't know. I've seen flies get modified in labs. Does that count? I don't think it does. When we look at the fossil record, it sure looks like it. We see these trajectories of variation that look like family trees, which really strongly implies a genetic lineage over a very long period of time. Does that mean these problems are just that these philosophers are bringing up, that Meyer, Berlinski, and Gelernter are bringing up, are that they're just kind of whataboutery? They're just like nitpicking? No, I don't think they are petty. I think they've got some weight to them and are very interesting questions. I think what we're looking at when we see what these questions really illustrate is that Darwinian evolution cannot be assumed in the blasé manner in which it has been assumed for the last 20 years to be a complete explanation of the origins of life. Certainly not the origins of light, not even perhaps the origins of the variety of life. I think it is a good explanation for a lot of the life that we see, but maybe not all of it. Maybe there's more in heaven and earth than fits within Darwin's philosophy. So I think what we might be looking at is an unfair standard that Darwinism is being held to, that has been built up by mathematicians and philosophers who were drawn to Darwin because of the beautiful simplicity of his idea. One of the philosophers, I believe it was Stephen Meyer, might have been one of the other ones, was sort of speaking with real pain about the feeling of letting go of this theory that he thought was truly beautiful early on in the discussion. So it's a marvelous little exploration of scientific psychology, I think. Because I think it's very underrated how driven by beauty scientists and mathematicians are. And it's very human, but it's not an epistemic compliment. I think it might be something closer to a bias. There's that famous line of poetry that equates, what was that line? That equates truth and beauty. That is all you need to know. Truth is beauty, beauty, truth. That is all you need to know. Preposterous. Nothing is less true. There's so much ugly truth out there. And there's so many beautiful lies. So many beautiful lies. Most of politics is beautiful lies. I don't know if you knew that or not. So anyways, that's my feeling on this. I think the challenges to Darwinian evolution, the mathematical challenges that come from chemistry, that come from the sort of theoretical precision and timing of mutations, and the time itself. We didn't have enough time from the any average rate of mutation you could possibly provide to get from 4.5 billion years ago to today to the level of complexity you see. These are really interesting arguments. They're really cool, and people should take them more seriously, I think, and look into them more. Do they conclusively prove that Darwinian evolution is wrong? No, I don't think they do. Do they demonstrate that Darwinism is incomplete? Very possibly. We might even say probably. So with that, I think I'll leave it at that. Thanks so much for listening. Hope that's some enjoyable food for thought. And take care.